Now, let us take a look how do we use the data to do the multi-class classification on grade and price. So if we are only looking at the binary classification, for example, on grade, we predict the y is 90 plus or 90 minus. If we do the binary classification on the price, the problem we define in this thesis is that we try to predict a y costs more than $29 or less than $29. Of course, for the region, we only have 2 areas, and that can be expanded for the further research. But in this thesis, we try to predict the region of coming from the new world or the old world. Now, if we transform the binary classification into 4 classes, that's what we call a multi-class classification. The grade will come into 4 different categories, and for the price, it will come into 4 different categories. If you still recall, for the data distribution, we have much more y falling into category of the 2, and then followed by category of 3, and then category of 1, which are the y less than 84 points, and we have a very teeny tiny amount of y's that are fall into category of 4. For price, it's a little bit different from that. For the price, we use percentile to evenly distribute the 4 different categories. So there are 25% of the y's that are less than $18. Another 25% of the y fall into a category of $18 to $29. Another 25% of the y fall into a category of $29 to $50, and for another 25% of the y, they are greater than $50. And that greater than $50 category of the y can vary from each other dramatically. Some, like we said, some of the y are cost more than $1,000, and that is being described in our box plot. So how do we do that? How do we do multi-class classification? In our example, there are 4 different classes. If we simply use what we have learned so far, we can build SVM for binary classification. And if we want to do 4 classes classification, we can divide the whole process into multiple stages of binary decisions. So let us take a look of a figure to explain how do we do that. So this is the structure of how we will be able to do the 4 classes classification. Let us use the grade as an example. So in the grade, there are 4 different categories. Category 4 indicating the grade is 90 to 100. Category 1 indicating the grade is less than 84 points. So what we can do over here is that we can use our first layer of SVM. We use the all data that we have to train the SVM for 90 plus or 90 minus. So now if we have a testing data set comes in, we can use this first SVM to predict is 90 plus or 90 minus. Then we can build the second SVM by feeding only the positive y's for the prediction of 90 to 94 or 95 to 100. And then we can, of course, build another SVM based on the 90 minus y's for a third SVM. So to transform a binary classification into 4 classes, multi-class predictions, we need to build 3 SVMs for us to make the prediction. So now let's take a look at this. For a y, a testing y that comes in, what we will be able to do is that we're feeding into the very first SVM and then try to predict this y is 90 plus or 90 minus. In this case, saying that it is predicted as 90 plus. So what it will do is that we can feed this data into the second SVM that we have built to predict its category of 4, which is 90 to 95, or category of 3, 90 to 94. So saying that it has been predicted by this SVM as 95 to 100, that indicates we have this Y being predicted as category of 4 as a first priority. And then the next possibility is, of course, the category of 3, and therefore we can actually provide a rank, a possible ranking for this Y. On the other side, thinking about this, even though the first SVM predicted this Y as 90 plus, we can still feed this data set into our third SVM and then make the prediction, saying that this Y is being predicted as rank number 2, that's between 85 to 89. That is saying we have the next possible guess for this Y after category of 4 and category of 3, because those are the first priorities of the predictions that is made based on SVM 1. The next prediction based on SVM 3 indicating it is going to be a category of 2, and of course the least likely is going to be the category of 1. And therefore, not only we can predict which one category this is, we can provide the whole possible combinations of the 4 different categories. So that is what this model can do, and that's how we will be able to make the predictions in this chapter. Of course, if we list out all kinds of different possibilities of the ranking for every single one, there are these possibilities. However, 3241 and 2314 are not possible because they are not falling into the category of the prediction for the SVM1, the very first SVM, because it either is going to group 3 and 4 together, or it's going to group 1 and 2 as the first 2 predictions. And that is what this methodology will be able to help us to do the prediction. And therefore, while we try to build the SVM model and then making the predictions, we have finding out some possible results that we can generate. So we're still using a 5-fold cross validation. Based on that, we trained the SVM1, the very first SVM, to predict the new world versus the old world classification based on the one review. The result is fairly consistent. 84% of the ones can be successfully predicted is coming from a new world or the old world. And of course, this is a simple binary classification problem that is being implemented in this chapter. Now let's take a look of the grade predictions. The layer 1 classification accuracy established an upper bound for the accuracy of the entire hierarchical classification system. So based on the grade, when we try to predict is 90 plus or 90 minus, based on the 5-fold cross validation, we also getting a very close to 84% to successfully predict is coming from the 90 plus category or 90 minus category. So this is the performance that the first layer of SVM can do. Now, if we take a look of the second layer, for the left one as well as the right one is predicting the category of 3 and 4, which means 90 to 94 or 95 to 100, versus 1 and 2 is below 84 to indicating that 85 between 89. So based on those 2 SVMs, we can also getting the accuracy of 85% on the SVM number 3 versus 95% of the accuracy on the SVM number 2. So the average wise is about 90% in the second layer. And therefore, if we combine the accuracy on the first layer and the accuracy of the second layer, the prediction accuracy as for 4-class classification is about 76%, which is considered pretty good because think about this. For 4 classes, if we just give a wild guess, the accuracy is about 25%. While we can get as high as 76%, this is actually a pretty exciting results that we can achieve. However, there's one hidden devil in these results. If you understand the data about this SVM, you will understand that we have actually very, very few wines that's coming from 95 to 100. So what this SVM, when we try to training this SVM, although the accuracy are all 95, and that looks fantastic, while we look into the details, we actually found out that the SVM class everything into category of 3. So all the predictions are category of 3. There is no prediction of category of 4. Since category of 4 is very, very little, all of those mistakes are being overlooked by the 95% accuracy. This leads to another chapter of what we call imbalanced data set. When your data set is highly imbalanced, this is kind of situation can happen to the data set. And therefore, one of the chapters in this thesis is discussing about this imbalanced situation. For the price, it's doing similar things. However, it is less accurate. Because think about this, it's much harder to look into the wine reviews and then predict the price, since wine reviews are more or less associated with its grade. However, how much you want to pay for, or how much does the winemakers charging a wine, is not really closely related to the wine review itself. And therefore, you can see that for the first layer of the price prediction, we can actually achieve about 75%, can successfully predict a wine is cost than $29 below or above. And then when it comes to the second layers of SVM, you can see that the accuracy is actually lower than what we can achieve over there. And therefore, for the second layer, upper bound is about 63%. When we combine the two accuracies together for a 4-class classification, the accuracy is only about 45%, still higher than 25% of the 4-class classification. And that is something that we feel is very interesting to use the wine reviews to predict the wine price. And therefore, that concludes this chapter's discussion about multi-class classification. In the following chapters, there's more details about the imbalanced data set. There's going to be about not only the multi-class, but what we call a multi-target classification that goes a little bit deeper into this area. That's about the chapter 4 that I want to introduce to you guys.